Hi, I'm Derek Robinson, a senior technical online course developer here at InterSystems, and I'm joined today by Gunnar Hammonds, a cloud engineer at InterSystems, to talk about InterSystems Network Connect. Gunnar, thanks for taking the time.
Yeah, hey, Dirk, of course. Thanks for having me.
So let's start with the basics here. As I understand it, InterSystems Network Connect is a little bit different than the other cloud services that are in our catalog here at InterSystems. Can you summarize kind of what this service does for the InterSystems Cloud Services users?
Yeah, sure. Yeah, so like you said, so most of our cloud services rely on the underlying Iris platform. Network Connect is not like that. Instead, Network Connect basically sort of serves as a hub for the other cloud services. Allows them to establish sort of secure network connections to a customer's private network through something like a VPN. So you can sort of think of Network Connect not as a standalone service, but sort of working in a supporting role for the other services that we offer, such as Health Connect Cloud.
Right, right. Gotcha. Okay, cool. And so when it comes to these networking topics, specifically VPNs, why is that so important for, say, interface engineers in Health Connect Cloud or other roles that are using InterSystems Cloud Services? Why are those topics so important to know about for people that may not be as familiar?
Yeah, sure. Yeah, so VPNs are super important because they're one of the big ways of establishing a connection between these cloud deployments and a customer's network. So one thing we probably want to talk about is the difference between a public network and a private network. A public network is something that is easily accessible by basically anybody on the internet. So effectively something like Google or InterSystems webpage, anybody can go in and access it. On the other hand, a private network is something that is cut off from the public internet and only authenticated users can access it. So private networks are very commonly used by organizations such as hospitals. Since they care a lot about security, they'll put their very critical systems inside of a private network because they don't want just anybody being able to go in and access them. They want only authenticated users to do that. That poses a little bit of a problem, though, for cloud deployments because cloud deployments don't live inside of these private networks, of course. They live on the cloud. So by default, they're not able to access any of the important systems inside a private network. So that's sort of where VPNs come in. It's in the name. It's called a virtual private network. So VPN connections are used to allow sort of simulate a link between a cloud deployment and a private network. They can allow a cloud deployment to access all the critical systems inside of a private network without actually geographically being inside of it. And so all the traffic that goes over VPN will have to pass over the public internet to go from the cloud deployment to the private network, but all of it is fully encrypted, so it prevents any bad actors from learning any details about what's going on inside of the private network. So setting up VPNs involves a lot of details, but thankfully through Network Connect, we automate a large portion of the process, so it makes it very easy for our customers to set up.
Right. Nice, yeah. And I know via working through some of these cloud services, I've heard quite a bit about Network Connect. So what do you say? Can we jump into the UI and take a look at what this kind of looks like for the user standpoint?
Yeah, absolutely. Yeah, so here we are inside the UI. So for this demo, we're going to try to connect these two Health Connect Cloud deployments I have, HCC Dev and HCC Prod. We're going to try to connect into a private network through Network Connect, which is the deployment you can see here on the right.
Yep.
So before we get into that, there's a couple of details we're going to want to note about all these three deployments. So for looking at this Health Connect Cloud deployment, just a networking detail, but you can see we won't really have to worry about many of the details for Health Connect Cloud for this demo. One thing we do have to care about is the CIDR block. The CIDR block is effectively the set of private IP addresses that correspond to this HCC Dev deployment. What you really want to note is that there will be some IP addresses that are assigned within a customer's private network as well. You just really want to make sure that this set of IP addresses does not overlap with anything inside your private network because that could cause some communication problems. So for example, I know that there are three different ranges that are used for private network IPs. They start with either 10, 172, or 192. I know for the private network that we're trying to connect to, all the IP addresses start with the 10 prefix. So for this deployment, I've chosen 172. And if we look at my prod deployment, you can see the same thing. It again starts with 172.
Yep.
So that's about all we'll have to worry about for those HCC deployments. One more minor networking detail to worry about is we can see looking at our Network Connect deployment. So this is sort of the hub for our communication. There's this field called ASN. This is what's referred to as a Border Gateway Protocol ASN. You don't have to worry too much about this. We'll talk a lot about it later. But just note that when you're creating the Network Connect deployment, make sure that this ASN number does not overlap with anything inside of your private network. So this is a detail, like with those CIDR blocks, you want to communicate with whoever your network administrator is to make sure there's no issues.
Right.
So that's that on sort of the housekeeping details. One thing to note when looking at these three deployments is that even though we have two separate deployments, so these are sort of two distinct units, In order to connect to our private network, we'll only need to use one single VPN connection, which is great. And that's because, like we said earlier, Network Connect is sort of working as a hub. If we didn't have the Network Connect functionality, each one of these deployments would have to have a separate VPN that would have to be managed to connect to the private network. But since we're using Network Connect as a hub, we only have to use one single connection. One thing to note, though, is that one single connection is only valid for one specific private network. So, like, for example, the private network of a single hospital, if you want to connect to, for example, 2 different hospitals, you have to have 2 different private VPN connections, each of which would have to route through Network Connect.
Right, right.
Yeah.
Okay, cool.
So that being said, we can sort of go into Network Connect and get started with setting up our VPN. To do that, I click in, I then go to this Configurations tab on the left, and this will open up the main page that you use to link both deployments and VPN connections into Network Connect. So we'll wait a little bit for this to load, but the first step in setting up the process is we need to actually attach our HCC deployments to Network Connect. Not only does the private network need to be connected in, but the HCC deployments as well. For this demo, I've already completed that for both HCC Dev and HCC Prod. As you can see here, they're both listed. You can see the attachment is complete, and you can see the listed CIDR block for each of them. But just for reference, if you were to do this yourself, in order to attach a new deployment, you go click here on this Attach Deployment button. You see here, I don't have any other HCC deployments that I connect to, but if I did, they'd appear here in a dropdown. I'd select it. I then click this grayed out Attach button on the right. It would start the attachment process. That takes a couple minutes, but it handles everything for you automatically. And once that's complete, your HCC deployment will be linked into Network Connect.
Right, right.
So,
okay, yeah.
Yeah.
Looks straightforward. And I'm just also going to quickly mention that for all of this stuff, there will be documentation as well that users can refer to for the things that Gunnar has already kind of set up previously during this video. So, yeah, for sure. Keep going.
Yeah, absolutely. So once that's done, we're sort of all set on the HCC side. Now what we need to do is sort of lay the infrastructure for a VPN connection. In order to do that, we go into this second table here on the bottom for active VPN connections. We can go in here, we can click Create VPN. So this will give us another form we can fill out the details for. The first one is the name. This is really mainly just used for administrative purposes, so you can put in whatever you like. Just for the purposes of this demo, I'm just going to put in demo VPN. Next, we have the gateway device IP address. So when you have a private network and you're trying to communicate over a VPN, obviously all the systems inside will be inside the private network, but in order to reach it from the outside, there will be one device, what's called the VPN gateway. This will be the only thing accessible from the public internet, and that's what we sort of need to point our VPN at. And we do that by specifying the IP address. I already know for the private network we're trying to connect to, I already know the IP address of our VPN gateway, so I can paste it in here. But this is a detail you'd have to ask your network administrator about. So now that we've done that, we can go in and collect, again, here comes up again, BGP ASN, Autonomous System Number. This is the autonomous system number. We'll talk about this more later, but this is what gets assigned to the gateway device. Again, it's best to ask your network administrator. There may be a preset value that you need to use, or there may be a new one you can come up with. But either way, no matter what you use, you just need to make sure it doesn't overlap with anything else on your private network. In this example, I'm just going to use 64513 because I've gone in and double checked. This doesn't overlap with anything. So that's all set. That's all the details we need. We can go and click Create. This will start the creation process. This does take a couple minutes, so we can wait for that. And once it's completed, we can check back in and finish the setup. All right, so now we're back. Looks like the VPN creation has finished. You can see down here we have demo VPN, and it's in the complete state. However, you will notice under tunnel 1 and tunnel 2, we have these red icons saying that the tunnels are down. So the tunnels are effectively 2 separate paths that can be taken when sending traffic over VPN. As you can see here, they are not set up. That's something that needs to be done before we can actually send traffic over the VPN. So the next thing that we need to do for that is to set up BGP peering over these tunnels.
Gotcha. And so for those who don't know, what is BGP peering? What does that refer to?
Yeah, sure. Yeah, so I think I mentioned it a little bit earlier, but just to explain, BGP refers to the Border Gateway Protocol. It's effectively a protocol that is used by VPNs to dynamically share routes from the private network to the cloud deployments. So if you're not familiar with a route, you can think of it as sort of like a map. It basically has a destination of what systems can be reached over VPN, and then it sort of says the path that can be taken to go there. So for example, over the VPN, we will share to the private network that they can reach these cloud deployments, and we'll say that the path to get there is the VPN. and vice versa in order for the cloud deployments to reach the private network.
Yeah.
And so that's something that can be done through the BGP peering protocol. So to continue the sort of analogy of maps, you can think we've created the VPN now. So you can think if we sort of built a new road between the cloud deployments and the private network. However, nobody inside the private networks or the cloud deployment has a map, so nobody knows that they can use the new road. So in order to share those maps, we're going to use BGP peering. We have to set that up. So that is a little bit of a technical process. It's something that's done automatically on the cloud deployment side, but it will require configuration on the private network side by the network administrator. Thankfully, though, the portal does make this a little bit easier. You can see in the Actions tab on the right, there's this here, which allows us to download a BGP configuration for this VPN connection. So what we can do is we can go in here. This shows we're doing it for the VPN connection. So this is when you have to reach out to your network administrator. These are sort of the nitty-gritty details, but you're going to have to know what model of VPN gateway they're using. I know for our demo, we're using a VPN gateway made by Viata. So I can go in here, fill out all these details that you'll have to ask about. But once you go in here, you can click download. We can give it 1 second. And yep, so there it download. You can see it says successfully downloaded config. It downloaded into my browser this text file. We can open up, we can view that. And it's pretty technical, but these are basically all the steps that the network administrator will need to do in order to set up BGP peering. So you can give this to them. It'll make their life way easier.
Right.
So this is something we'll set up for a demo sort of off screen, but we'll wait for that to finish and then we can come back. Okay, so now we're back. We've set up the BGP peering on the back end. You can see both our tunnels are now up, which is awesome. That means that we're sharing the BGP routes between the VPN and our Network Connect hub. So that means that the sort of the map between the two sites is being shared. That means that our dynamic VPN is set up.
Right. Nice. And so you mentioned dynamic VPN. I see routing type there is dynamic. Are there other types of VPNs that people would see here or that they should be aware of in this process, or is it typically just going to be dynamic?
Yeah, Derek. Yeah, that's a good question. So there's two different types of VPNs that we use. There's dynamic VPNs, which you're talking about. There's also static VPNs. So as we've mentioned, dynamic VPNs use BGP peering that allows them to automatically share routes between the private network and cloud deployments. Static VPNs, on the other hand, the sharing of the routes is sort of a manual process. That means that every time you want to go in and update the routes, you have to type it in and sort of update it and do it that way. So we prefer dynamic VPNs for a couple of reasons. One, as we previously stated, with dynamic, the route sharing is more automated. This is great for network administrators on the private network side because it allows them to go in to update sort of what routes, what systems inside the private network they want to be accessible without too much trouble. The other big reason is that with dynamic VPNs, it makes it much easier to switch between these two tunnels. So effectively, the reason we have these two tunnels is for extra resiliency. Say if some part of the infrastructure that was supporting the first tunnel goes down, traffic could be switched over to the second tunnel. With dynamic VPNs, the switch over is a much more graceful process. You can have sort of a single unit of traffic, and in between that communication, if the part of the infrastructure of the first tunnel goes down, the switch over to the second tunnel can be pretty much seamless. With static VPNs, it's much more difficult to achieve that sort of seamless switchover. And so when you're working with systems that require very high uptime, such as healthcare systems, they're able to seamlessly switch between these two tunnels, even in the event of network infrastructure failure, is super important. So for all those sort of reasons we listed, we recommend that customers use dynamic VPNs if they're able to support it. Static VPNs are a valid option. We're working on increasing our support for static VPNs within the portal, but we still strongly recommend that customers use dynamic VPNs.
Right. Nice. Okay, that makes sense. So as a user here, I see two green check marks. I see the word complete. Am I ready to go? Is everything set up, or are there any final steps here before we roll this out and really consider it done?
Yeah, that's a great question. So yeah, you may think you see these two green check marks down there. You may think you're all set. That's really not the case. There's one more step we need to do, which is syncing the routes from Network Connect to the deployment. So if you can see this diagram here, you can see in the bottom we have our office. This is sort of what we're referring to as the private network. And on the top, you can see these three deployments. This is each Health Connect Cloud deployment. In this example, there are 3 of them. And so during the process of the dynamic VPN, we sort of set up this blue arrow that points from the office to Network Connect. So we're able to share all those routes or maps from the office to Network Connect and vice versa. The thing is, though, that all of those routes are going into this cluster of blue route tables you can see surrounding Network Connect. These route tables are where you store those routes. The problem is that the routes not only need to be aware by Network Connect in their route tables, they also need to be shared to these orange route tables that are next to all these deployments. And so this is a process that needs to be triggered manually. All we need to do is take the routes that the office has shared to Network Connect that are in these blue tables here, and we need to sync them, send them to these orange route tables at the top for the deployment. Once that's been complete, the deployments will effectively have the route. If they want to reach the private network, they can read into these orange tables that say, first, I need to go to Network Connect, then they'll reach Network Connect. At that point, the traffic can look into these blue tables here, and it'll say, okay, if I want to reach the office or Network Connect, this is the path I can take. And in this case, that path will be the VPN. So even though triggering the route sync is a manual process, the portal makes it pretty easy. You have to do it deployment by deployment. So you can see right here for HCC Dev, we have this little refresh icon. We can click here. You can see it says sync routes. We go in, we can click this. So syncing routes is progress. We can wait a second. And we've done that. Now we'll just have to go in and do the same thing for HCC Prod. Go in, click the refresh icon. All right, and the route table sync was successful. So at this point, we pretty much completed the setup. And so now if we go back to our diagram, we can sort of see what we've done so far. We've set up the VPN, this blue arrow to Network Connect. That's sharing the routes from the office to Network Connect, vice versa. And just now, we've manually synced those office routes to the deployments. So now the routes have been shared across our entire sort of virtual network. Deployments should be able to read into the route tables, get to Network Connect, get to the office, and traffic from the office should be able to go into the Network Connect, read the route tables, and go to deployment. So at this point, traffic should be able to freely flow in both directions, and we should be all set.
Great, great. Yeah, that's awesome. So with that all set up, any final tips or parting words that you'd give to a user who's just finished setting this up and is ready to roll it out to their production systems?
Yeah, so I'd say one thing you definitely want to take a look at before you start working on getting everything working in production is you want to do what's called a failover test of the VPN. So that's going back to earlier when I was talking about switching between these two tunnels in the event of a network infrastructure failure. Like I said, when you're using a VPN, that's something that can be done very seamlessly. But when we're working with systems where very high uptime is expected, it's always something you want to double check. So we very strongly recommend that you can simulate a network failover on your end to make sure that traffic can seamlessly switch from one tunnel to the other. That's something that will be very good just for the peace of mind, if nothing else, and it's something that our team can assist you with if needed.
Right. Nice. That's great. Well, Gunnar, thank you so much for taking the time to show us about InterSystems Network Connect.
Yeah, of course. Yeah. Thank you for having me, Derek.